2.2, we're going to talk about the reciprocal function. The reciprocal function is an inverse function. The parent function, let's start with that. The parent function of a reciprocal is y equals 1 over x. That's the parent function. Now, in that parent function, just like we talked about yesterday when we were graphing with an inverse when you have x on the bottom, when you sketch a graph for this parent function, it falls in the first and third quadrants. So just to see how much you guys remember, I bet you can totally handle this. First thing I'm going to ask you, example number 1. Can you describe the transformation? So if I start by saying we have y equals 3 over x minus 2 plus 5. So this 3 on top, instead of a 1, what do you think that 3 is going to mean? Stretch of 3. I start by saying stretch of 3. Okay, in the bottom, instead of having x, I have x minus 2. What do you think that means? Right 2. And at the very end, we have plus 5. Up 5. All right, so I know you can kind of picture where we're going with this, but there's some vocabulary we needed to really talk about before we get into today's lesson. Okay, so I'm going to bring my graph from up there down here for a moment. So here's my graph of the parent function, which was y equals 1 over x. We said we had a curve in the first quadrant, and we had a curve in the third quadrant. All right, now those curves are approaching each of those axes, the axis, x and y axis, but it's not touching it. When you have your graph approaching a line and not touching it, it's called an asymptote. So that's the line, or a line, the graph approaches, but does not cross. So in this case, we actually have asymptotes at each of those axes. So an equation for the y-axis, it's a vertical line. If it's a vertical line, it's at x equals 0, right? That represents the y-axis. And for the x-axis, that's a horizontal line, so that's y equals 0. Those are asymptotes. All right. So at the same time, I want to talk about domain and range. All right. So let's talk about domain first. In the domain, that's your x values. Your graph starts here with an arrow pointing at negative infinity, right? And it goes all the way, it gets closer and closer to 0, but it can't touch it. Can't equal it. It can get really, really close to 0, but it can't equal it. So we're going to put it in parentheses. Then it jumps right over that x equals 0 and starts over here at 0 again on the other side. So we're going to put a u, start back at 0. And we're going to go all the way to positive infinity. So you'll notice where the asymptote is where x cannot exist in your domain, right? Okay. Let's talk about the range. Remember, the range is your y values going from the bottom to the top. Same deal, right? It starts at negative infinity, goes all the way up to it's approaching this x-axis, which is y equals 0. It jumps over it, starts back on the other side of the y-axis at 0, and goes to positive infinity. So again, it can never touch where that asymptote is. It cannot exist at that one spot. Okay, so we're good so far? All right. here's where I want to start. Example number 1. Example number 2, thank you. Example number 2. In problems. 4 problems. 8 through 12. It's going to ask you to do a few different things. 1, it's going to ask you to graph the function. After you graph the function, it's going to ask you to state the x and y intercepts. After you state the x and y intercepts, state the asymptotes. Remember, those asymptotes are line equations that your graph approaches but can't cross. And then domain and range. All right, so maybe you're given the function y equals -2 over x. All right, so what is a -2 going to do? Yeah, it's going to flip it so you actually end up with it in the second and fourth quadrants. Again, you're approaching those lines but never crossing them, right? Okay, so we have the graph of the function sketched up there. State the x and y intercepts. Well, what is an x and y intercept? Exactly. We can't cross the x or y intercept, right? We don't have any of those because you can't touch the x or y axis. So there are no x or y intercepts. Axis, or the asymptotes. We have an asymptote right here on the x-axis, or on the y-axis. That's x equals 0. We have another asymptote right here on the y, or on the x-axis. That's where y equals 0. And last thing, we got domain. Again, it starts at -infinity, goes up to that asymptote at 0, jumps over the y-axis, starts back at our 0 and goes to infinity. And then your range starts at the bottom at -infinity, goes to 0, jumps over the x-axis, starts back here at 0 to infinity. Nope, and we're going to get to that in just a moment. Okay? All right, so on those first 3 problems you have, the only thing that's going to vary on those 3 problems is what your graph looks like. All right? Your x and y intercepts, they're not going to exist. Okay? Your asymptotes are going to be at x equals 0 and y equals 0. And your domain and range. All right? Good? All right. Example number 3. On example number 3, we are covering 14 and 16. All right. And it's written kind of funny in the book, so I want to make sure I explain what it's asking. It says, identify the effects of the graph y equals 1 over x to y equals -3 over x. So when it says identify, that's the same as saying, how does it translate? What's it doing? So what does that negative tell us to do? Flips. And then when we go from 1 to 3, what does that tell us we're doing? And stretch 3. All you got to do for those couple problems. Easy, I agree. Example number 4. All right, for example number 4, it's going to ask you to sketch the graph and identify domain and range. All right, but now we're going to start to have some fun with it. Let's say I have y equals 2 over x minus 3 plus 1. So before we get into that, who wants to describe how this changes it? What did it do? The 2 on top is a what? Stretch 2. Good job, Chris. Stretch 2. Huh? Good. Right 3. Nice job, Colton. Right 3. Awesome. Right 3. Up 1. Okay. It was awesome. So here's my graph. Now, originally, it would have been on our x and y axis. But you guys just told me we're going to go to the right 3. So I'm going to take this axis and I'm going to move it to the right 3. So my new axis is right here. I moved it to the right 3. Then Colton said that we're going to go up 1. So I'm going to move the x-axis up 1. So my new axis is right here at 1, right? Questions so far? So now, this graph, because it's positive, was supposed to fall in the first and third quadrants. If this is my new axis, it still falls in the first and third quadrants. You're approaching those asymptotes, but never touching them. Right, you never touch the asymptotes. You get really close, but you never touch them. Okay? So questions on the graph itself. So once you know how it translates, makes it super easy to sketch it in. Got to talk about that domain and range, right? Domain. Again, your domain's always going to start at negative infinity because it's starting here. And it's approaching what value for x? 3. Good. Then it's going to jump over 3, starts back on the other side of 3, and to infinity. Good. How about the range? Yep, so we're going to start where? Negative infinity to 1. Good. Jump over 1. Yes, 1 to infinity.
So I have a question. Why
Yeah.
should 2 be a negative 2?
And the top?
Yeah.
Oh, so it would flip, which means it'd be in the second and fourth quadrant. Yep, and that's the only thing that would be different. Your domain still follows the same rules. Everything, yep. Never touches the asymptotes. Okay? All right. If you guys are good with that, that covered the problems 18 through 24. All right? That was 18 through 24. I better put that here. I know how you guys like to see that in the notes, right? Last example. Example number 5. Example number 5 is going to cover your last 2 problems, 26 to 28. And it says, write an equation for y equals 2 over x with asymptotes at x equals 3 and y equals 4. All right, so we're going to start with this. We have y equals 2 over x. If I'm moving my asymptote 3 to the right, what does that tell me I'm going to put in my equation? Minus 3, right? That tells me I'm going to the right 3. And if I'm moving up 4 on the y-axis, plus 4. Last 2 problems, all you got to do. Do you guys want another one? No, that's good. Any questions? Lucas, Golden, Chris, Lucas? No, we're all good? All right, awesome sauce. Oh, asymptote. Yep. Yeah, I just abbreviated asymptote after the letter P. Next time I'll write it all out, Irene, okay?